Hello everyone, welcome to day 2 of STP series. Guys, this is day 2 of spanning tree protocol series. In day 1 we had discussed very basic things about spanning tree, like why we come up with STP, how STP works, what are the root bridge election criteria, what are the designated port election criteria and root port election criteria. And today in this video we will discuss STP estates and path manipulation. So today we are going to cover two topics. First one is path manipulation in a spanning tree, and second one is STP estates. We have 5 types of estates in a spanning tree protocol, like disable, blocking, listening, learning and forwarding. So we will cover these 5 types of estates as well. But before starting today's session, let me remind you what we had discussed in last class. Suppose guys, I have 3 switch 1, switch 2 and switch 3, like this. This one is 0/0, this one is also 0/0, this one is 0/1, this one is 0/0. Suppose MAC address of switch 1 is 0A, MAC address of switch 2 is 0B and MAC address of switch 3 is 0C. So tell me first of all, which switch will become root bridge? Guys, I am going to discuss RPC here, root port cost, that how switch calculate RPC. RPC is root path cost, means total cost to reach root bridge. So every non-root bridge switch will calculate RPC to reach root bridge. Yes or no? We had discussed in last class that every non-root bridge switch will calculate RPC to reach root bridge. So first of all, tell me which switch will become root bridge. Switch 1, because switch 1 has lowest bridge ID. What will be the bridge ID of switch 1? 32768 plus 0A. This one is by default priority and 0A is base MAC address. What will be the bridge ID of switch 2? 32768 plus 0B, and bridge ID of switch C will be what? 32768 plus 0C. So switch 1 has lowest bridge ID, so switch 1 will become root bridge, right? So this port, all ports of root bridge will become what? DP, because root bridge switch will transmit superior BPDU, right? So switch 1 will send BPDU from this interface, from 0/0. In that BPDU, what will be the bridge ID? Bridge ID will be 32768 plus 0A. Yes or no? What will be the cost? Cost will be 0. RPC, this one is RPC. Total cost to reach root bridge from root bridge is 0. राइट, रूट ब्रिज से रूट ब्रिज पर रीच करने की कॉस्ट क्या होगी? 0 हमेशा. एंड नॉन रूट ब्रिज स्विच विल ऐड देयर रिसीविंग इंटरफेस कॉस्ट, right? How non-root bridge switch calculate RPC to reach root bridge? They will add their own receiving interface cost, and you know by default cost on Ethernet port is 100. By default cost on fast Ethernet link is 19, and STP never reveals formula to calculate cost, right? So this is by default cost. You can change it, but I don't know what is the formula to calculate cost. So switch 1 is my root bridge and it will send BPDU. In that BPDU, root bridge ID will be this one, 32768 plus 0A. Cost will be 0. Sender bridge ID will be same, 32768 plus 0A, right? And after that sender port ID will be 0/0, and then receiving interface, so it will not add receiving interface. When switch 2 will receive this BPDU, it will add their own interface cost. So suppose this link is my fast Ethernet link, this one is my fast Ethernet link, so it will add cost 19 here, right? So when switch 2 will send BPDU to switch 3, root bridge ID will be same, 32768 plus 0A. Cost will be what? Cost will be 19. Means total cost to reach root bridge from me, from switch 2 is 19, and sender bridge ID will be 32768 plus 0B. Now who is sending this BPDU? Switch 2, and sender port ID will be 0/1. That means 128.1. When switch 3 will receive this BPDU, switch 3 will add their on receiving interface cost. So what will be the total cost to reach root bridge from switch 3? It will be 38, because cost which is coming in BPDU is 19 and cost of my interface is also 19. So total cost from R3 to reach switch 1 is 38. So suppose here is one more switch, switch 4, and this switch is connected to switch 5, and switch 5 is also connected to switch 3. So switch 3 will receive BPDU on this port as well, but here cost will be what? Bridge ID will be same, root bridge ID will be same, 32768 plus 0A, and cost will be 19 plus 19 plus 19. So via this path cost is higher, so that means switch 3 is receiving superior BPDU on 0/0. So this port will become what? RP. In the same way this port will become what? RP. Okay, out of these switch, suppose my topology is like this switch 1, switch 2, and here I'm connected to link 0/0, 0/1. This one is my 0/0, this one is 0/1. Suppose MAC address of this switch is 0A, MAC address of this switch is 0B. This switch will become root bridge. So all ports of root bridge will become what? DP. From both port this switch will send BPDU. Switch 2 will receive superior BPDU on which port? On both port. Root bridge ID will be same, tie. Then they will check cost. Cost will be 19, right? Cost is tie. Then they will check sender bridge ID. Sender bridge ID will also same. Then they will check sender port ID. So here you can say sender port ID is list. So on this port it will receive superior BPDU. So this port will become RP and this port will become alternate. As you know, as we had discussed in last class, that on a single non-root bridge switch there can be only one RP, and on a single segment there can be only one DP. On a single segment there can be only one DP. So you can see here on this segment there is only one DP, on this segment there is only one DP. So this port cannot become DP, or this port cannot become RP, because on a non-root bridge switch there can be only one root port. There can be only one root port. On a single non-root bridge switch there can be not more than one RP. There can be not more than one RP. So RP is already available, this port is RP, so this port will become what? Alternate. So all traffic of user will be transmitted by switch 1 from this interface, from 0/0. So suppose here is user and here is also user. If these two users want to communicate with each other, switches will use this link to forward traffic, yes or no? But if I want to use this link, I want to manipulate path, I want to use this link. What I can do, I can increase the cost of this link. If I will set cost 20 over here, by default cost on fast Ethernet link is 19. If I will set 20 here, so now switch will not check sender port ID. Before sender port ID, switch will check what? Cost. And see here, cost is 20 on this port and cost is 19 on this port. So this port will become RP. Now switch 2 is receiving superior BPDU on 0/1. Yes or no? In the same way, here in this topology I am going to perform path manipulation. Fine guys. So see, this one is my D1. These two are distribution layer switch and these two are my access layer switch. As you can see, access layer switch are not directly connected with each other. Access layer switch are connected to distribution layer switch. And D1 is my root bridge. This one is my D1, this one is D2, this one is A1, and this one is A2. Access layer switch, distribution layer switch. So this switch will become what? Root bridge in this topology. So all ports of this switch will become what? DP, DP and DP. Yes or no? Now we need to calculate RP on every switch. So tell me, on this switch which port will become RP? So this switch is receiving BPDU on this port also, on this port also, and on this port also. So on which port this switch is receiving superior BPDU? On this port. Yes or no? So this port will become RP. Why on this port? Because cost is 19. On this port cost is 38. On this port cost is 38. Yes or no? So this port will become RP. on this switch this port will become RP, and on this switch this port will become RP. These are DP. Let me talk about this segment. On this segment, which port will become DP? Because RP is already available on both switch, so one port will become DP and one will become alternate. So tell me which port is sending superior BPDU. To identify DP, you have to identify that which switch is sending superior BPDU on this segment. On this segment, which switch is sending superior BPDU? Switch 2 is also sending BPDU, and switch 3 is also sending BPDU. In BPDU of switch 2, root bridge ID is 32768 plus this MAC address, right? In the BPDU of switch 4 also 32768 plus this MAC address of root bridge. Cost will be same from both sides. Cost will be 19 from here also and 19 here also. Then they will check sender bridge ID. Sender bridge ID is lower of switch 2, so this port will become DP. Yes or no? This port will become DP, this port will become alternate. This one is RP, this one is RP, this one is DP, 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 this is RP. And on this segment also this switch is sending superior BPDU, so this port will become DP and this port will become alternate. Yes or no? So if this machine wants to communicate with this machine, 10.1 wants to communicate with 10.2, traffic will go to switch 3, switch 3 will forward to switch 1 to root bridge, and root bridge will forward to switch 4, switch 4 will forward to PC. Yes or no? Means they will use this path, right? They will use this path. Yes or no? Whenever user want to communicate with each other, this user path will be this one, right? My traffic will be flow like this. Suppose here is one user, this user wants to communicate with this user, flow will be this port is RP, right? This port is RP, this port is DP, and this one is alternate. So switch 2 will learn MAC address of this switch on which port? On this port, on RP, because this is DP, this one is block. So block port will never transmit frame. Blocking port can only receive STP message. They cannot receive end user data, right? So switch 2 will learn MAC address of this PC on this port. So it will, whenever this machine will send traffic for this user, switch 2 will forward to root bridge will forward to switch 4, and switch 4 will forward to, so path will be this one. Yes or no? Now I want to manipulate path. Suppose when this user wants to communicate with this user, I want to use this link. I want to use this path, or I want to use this path. Fine. I don't want to send traffic like this. So what I can do? If I want to send traffic like this, I have to make this port as RP, root port. So this port will become what? Block, alternate. So it will not learn any MAC address on this port. Yes or no? Yes or no? So question is how to make this port to RP? By increasing cost of this link. Why this port is RP? Because switch 3 is receiving superior BPDU on this port, because here cost is 19. Okay, so this one is Ethernet link, so here cost is 100, and here switch is receiving cost 200. So if I will configure cost 300 here or 201 here, definitely this port will become what? RP. So first of all, let me show you guys how to make this port to RP. So go to switch number 3 and see which port is RP now. So a spanning tray. So there are multiple ports are up. Let me down some port. I am using Ethernet 1/0, 1/1 and 0/1. So go to config T, interface range E. I am not using 0/0, so I will down this interface. After that E, 0/1. I am using 0/1. No, I will down 0/1 as well. I build on 0/2. No, I am using 0/2. I build on 0/3. I am using 1/0 and 1/1. Okay, so let me down this interface range. Here is A and say shutdown. Right now you can check. So a spanning tray. So which port is RP? 0/2. This port is my RP. Now I am going to increase cost of this port. Go to interface E, 0/2. A spanning tree for VLAN 1. By default on switches PVST plus is running, right? So after that cost, a spanning tree for VLAN 1 and cost is, I am going to set 201 over here. Now tell me which port will become RP. So a spanning tree. Now 1/0 is RP. Now 1/0 is RP. So this switch will learn this MAC address of PC2 on which port? On 0/1. It will learn this MAC address on this port now, because this is RP and this port is now blocking alternate. Yes or no? But on switch 2, which port is RP? This port. So it will forward to root bridge. Now if I want to send traffic to directly switch 4, what I can do? You have to configure this switch so that this switch will learn this MAC address on this interface. So this port is block, right? This is your alternate port, right? So how you can configure this, how you can make this port as RP? So RP is now this port. Here if I will increase priority, here I will increase cost. So here cost is by default 100 and here cost is 200. So let me configure cost 201 here, so that this port will become what? RP. This port will become RP and this is DP. So it will forward traffic to switch 2 and switch 2 will forward to switch 4. So communication will be happen like this. Yes or no? So on switch 2 by default, which port is RP? Enable. So a spanning tree. RP is your 0/0. I am going to increase cost on interface is 0/0 and a spanning tree for VLAN 1 and cost is again 201. So a spanning tree. Now which port is RP 0/0? Wait guys, root port is 0/0, cost is 201, here cost is 200, here cost is 201. So now you can see root port is E 0/2. Now 0/2 is what? Root port. So this port is now RP. This port is now RP. So this switch will learn this MAC address on this port and this switch will learn this MAC address on this port. Yes or no? This switch will learn this MAC address on this port and this switch will learn this MAC address on this port. Now let me talk about switch 4. Switch 4 will learn this MAC address on this port and switch 4 will learn this MAC address on which port? On this port. Yes or no? Because this port is RP, this one is DP, go to switch 2, see here 0/3 and 1/0 is designated port. This one is DP and this port is RP. This one is RP. One slash 0 is RP, right? So traffic flow will be like this, right? Now if I want to send traffic like here to here, then here to here, then here to here, right? You have to make this port as RP. You can decrease priority so that once this port will become RP, this switch will forward traffic to root bridge and root bridge will forward to switch 4. So this switch, root bridge switch, will learn this MAC address on this port. Yes or no? Because this port will become what? Not DP, RP. You have to make this port as RP also, right? Okay, so this is manipulation, and I want to make this switch 2 as root bridge. What you can do, you can change priority, you can decrease priority here. Okay, if I want to send traffic, I want to connect one link between switch 3 and switch 4, and I want to send traffic directly from switch 3 to switch 4 like this. What I can do, I can make this switch as root bridge, so definitely this port will automatically become RP, this port will become DP. But in real time you will never make access layer switch to root bridge. Your root bridge switch will be from distribution layer switch. Okay, now let me discuss estates. So guys, on any switch you can verify. So let me check on this switch. So a spanning tree, here you can see role of this port is root port and state is forwarding, and role of this port is alternate and state is blocking. So we have 5 types of state. First one is disable. Let me discuss one by one. First one is disable. Second one is blocking. Third one is listening. Fourth one is learning, and fifth one is forwarding. So disable is like shutdown, means port is not up, you have run no shutdown command maybe. So if port is down, state of that port in a spanning tree protocol will be disable. And whenever port will come up, first of all port will move in blocking state. First of all port will be move in blocking state, and within nanosecond port will be moved from blocking to listening. And in listening state ports will spend 15 seconds. In listening state port will spend 15 seconds. Then after 15 seconds port will be moved from listening to learning, and in learning state also they will spend some time, 15 seconds, and then port will be moved in forwarding state. So it will take 30 seconds. It will take how many seconds? 30 seconds to come in forwarding state from blocking state. So my question is, why blocking state are there? Why blocking state are there? So that loop cannot form, right? Suppose I have a topology like this. Switch 1, switch 2, switch 3. Suppose this one is my root bridge, this one is non-root bridge. So this one is DP, RP, alternate, and DP. Fine. Suppose if this link will goes down, right? Switch 3 will start receiving BPDU on this port. So actually switch 3 is receiving BPDU on alternate port, on blocking port, but switch cannot send BPDU, or switch cannot receive user data. So switch is receiving BPDU on this port also. So this port will become what? RP. And when this link will come up again, so now switch 3 is receiving superior BPDU on this port. For some time both port will be become what? RP. We will discuss this thing in upcoming video. You will came to know that how two ports will become RP at same time, and if two port will become RP on non-root bridge switch, loop can be formed there, right? Loop can form. So that's why we have this state, blocking state. First of all, ports have to go in blocking state, right? Then they will move in listening state, then learning state, then forwarding state. If port will come in listening state directly, then there is chance of loop, right? There is chance of loop. So that's why we have this state, blocking state. But switch port will not spend time in blocking state. Very quickly they will move in listening state from blocking state. Okay, so state is disable, then blocking, listening, learning, and forwarding. Okay, what is the use of switch port? To send BPDU and to receive BPDU, to send data and receive data, and learning MAC address. These are function of switch, as you know. So guys, in disable state, switch cannot send BPDU, switch cannot receive BPDU, switch cannot send data, switch cannot receive data, and switch cannot learn any MAC address. If state is blocking, switch cannot send BPDU, switch cannot receive BPDU, switch cannot send data, switch cannot receive data, and switch cannot learn any MAC address on that particular interface. Fine. If state is blocking, on blocking state, definitely switch cannot send BPDU, but switch can receive BPDU. Switch can receive BPDU, but switch cannot send data, switch cannot receive data, switch cannot learn any MAC address, right? So blocking state, as you know, STP puts all interfaces either in forwarding state or in blocking state. So blocking state ports whose state is blocking can receive BPDU only, cannot receive data, cannot learn any MAC address, right? And state is, next state is listening. In listening state, switch can send BPDU as well, and switch can send BPDU. Yes, switch can send BPDU in listening state, right? And switch can receive BPDU as well. So in listening state, switch will start sending BPDU, and switch will start receiving BPDU also. So switch is receiving BPDU from blocking state, right? So here switch will start sending BPDU, but still switch cannot send data, and switch cannot receive data in this state, and switch cannot learn any MAC address in this state. But in learning state, switch can send again BPDU, switch can receive BPDU, switch cannot send data, switch cannot receive data, but switch can learn MAC address. Here in learning state, switch start learning MAC address, switch can learn MAC address, right? And in forwarding state, ports can send BPDU, port can receive BPDU, port can send data, port can receive data, and port can learn MAC address as well. So these are states, 5 states. Disable means shutdown state. For a very less time, ports will come in blocking state to avoid loop. After that state will be moving listening state. In listening state, ports will start sending and receiving BPDU, right? After that state will be moving learning. In learning state, they will start learning MAC address, right? They will learn MAC address. And in forwarding state, they will start sending data and receiving data. Fine. So these are 5 states of STP. So guys, if you have any doubt, please let me know in comment. And if you have learned something from this video, if you don't have any doubt, please hit on like button. If you haven't subscribed this channel, please subscribe this channel. That's all for today. We will meet soon in next video, right? Then we will discuss maybe topology change. Next topic is topology change in STP. Fine. So this is path manipulation and states in STP. Okay. So thanks for watching. Bye bye.